Good afternoon.
After 2 hours of lecture on the introductory part of multivariate statistical modeling, today we understand some of the quantitative part of statistics. I start with univariate descriptive statistics with a hope that you have some preliminary idea on statistics, particularly the univariate descriptive statistics. Contents for today's presentation include population and parameters, discrete and continuous probability distribution. In the process, probability mass function and probability density function will also be defined and deliberated.
And we ended that lecture with prerequisites for the course. Prerequisites for this course or subject. And what we have described there, that basic statistics is one of the prerequisites, and I told you that you also required to know matrix algebra a bit. Now, under basic statistics, the univariate descriptive statistics and univariate inferential statistics. Are important. So, again under univariate descriptive statistics, usually the central tendency and dispersions measure and dispersion, these two issues are described under descriptive statistics. Under inferential statistics, estimation and your hypothesis testing. Under estimation, there will be point estimation and interval estimation. Okay. Today we will, in this lecture, we will describe this one, univariate descriptive statistics. You see the content of today's this lecture. We will start with population and parameters, then we will describe probability distribution, particularly the normal probability distribution. Then we discuss sample and statistics, followed by measure of central tendency, measure of dispersion and followed by references. Now, do you have any idea about population? What do you mean by population? General sense, we say that the population of West Bengal, population of India, but in statistics this population has much broader sense. For example, in last class we have described one example, that a small company doing business in a city, So, the company has a production system. Can it be a population? if you define population from statistics point of view, population is the entirety or the totality, the whole. Population, the entirety or the totality, or we can the whole. When we talk about the population of West Bengal, that means each and every residence, legal residence of West Bengal is considered. From the production system point of view, this system, this word also represent population, the way we understand application of statistics. So, the system also is synonymous for us, it is also population, because system can be characterized by different variables. For example, for this company there are profit, sales volume, absenteeism and so many other variables where we have discussed. So, these are basically the variables which characterize a population or a system. Another word could be for us, that is a process. A process also we can think in this line also, the process can be from our purpose point of view. A process is something where transformation or activities taken place, activities or transformation takes place. For example, you give inputs as raw materials and the process, production process, it converts into value added output. Value added output. Now, if we consider the total life cycle of this process, then it will produce a large number of items. So, large number of items will be produced. All items collectively is the entirety, the totality or the whole. So, that means with respect to the items produced by this production process, we can define population. From if you go to the service sector, for example, the healthcare system or banking system, there also you can define population. So, essentially if you want to define population and you require to keep in your mind two things, that when I talk about the population of West Bengal, suppose this figure, let it be the portion. Now, the hilly regions, population at the hilly region, that is different than the population in the west of West Bengal or south of West Bengal. Now, for a particular purpose, you may be interested to understand what is the educational status of the people of the hilly people of West Bengal. Then what is happening? You are making a boundary, creating a boundary for the system. So, this boundary is the hilly region. So, in that case your population is this hilly region only. Now, if you think from the voting point of view, suppose the election time, so this end all the legal voters, they go for voting. In that case, all the voters of the total West Bengal, they are the population. So, in that sense, what is happening? That means, if you really want to define population, the boundary is very important. Getting me? Boundary in the sense, if you go, you come back to again the manufacturing scenario. In manufacturing scenario, you will find out that the total production system may composed of several subsystem, that for example, this may be machine 1, machine 2 and machine 3, and they are doing different operations. Raw material coming here and transformed through machine M1, then going to machine M2, some other activities are going on. Now, if you are interested to infer something about machine 1, suppose you want to infer something about machine 1, then your population is this. If you think that there are some common characteristics applicable to all the machines, then you may be interested to see the totality including all the machines, then your population will consider all the machines. This is very important, and unless we understand population, there is no use of statistics, because statistics is used to infer about the population. Inference related to many things. During in inferential statistics, we will be telling you what are the different inferences possible, but for the time being, you please understand that when we talk about population, we talk about a system or a process. Okay. And why we require to study the process of the population? Because we want to understand the behavior of the process or the system, or in terms of, or that is basically population. We want to study the behavior. Now, if you see the size of population, what will happen? Population can be finite, can be infinite. When I am talking about, suppose the production of a process for 1 year, number of items produced per year, and if that is my population, then it is a finite population. So, time is another aspect which also used to define the population. So, one is the boundary, another one is the time. So, this is basically boundary in the sense space boundary, and time is the time boundary. If you go for the entire life cycle of a process, then what will happen? Can you count that what is the what are the number of outputs? It is very, very difficult. So, if we talk about the entire life cycle, total time of the life of the process, what will happen? The number of items produced will be countably infinite. Okay. Whether countably infinite or infinite, we will basically define in statistics in two sense. One is that your population will be finite population or infinite population, and finite population mean the size is known, which is n. For example, number of items produced by a production shop in 2012. Infinite population, size is infinite, number of items produced, that is on the life cycle of the process, that is countably infinite. If you need further explanation, as I told you in the last class, that experiment, random experiment is the issue in statistics, deals with random variables, and random variables comes from random experiments. Basically, we generate random variable based on the experiments conducted. So, if we do one experiment like this, you see this figure, inside this, if I say this is basically a arm, then inside this there are red and white balls. Now, you pick up one ball, next one ball, like this, one after another, without replacement. What will happen? After some time, there will be no ball to pick up, experiment will end. this is finite population. Now, in the other case you see that what you will do in the second experiment, you pick up again replace. So, what will happen in that case? In that case the number of ball will never exhaust it. So, there are so many balls, red, white, what you are doing, you are picking up and finding out whether it is red or white. So, either red or white. So, you are counting that red, okay. Then again you are replacing this. So, similar manner you are continuing the experiment. You will need the size of the population. What will happen? The number of balls will remain as it is. From experimental point of view, it will never end. So, this is what is infinite population. In statistics, most of the issues what will be discussed later on, we will consider infinite population. So, in reality it may not be 100% true that all populations are infinite, but countably infinite populations are many, and for our practical purposes, if we consider this infinite population, there is no problem. Okay. Population behavior, if you measure, you require to know that what are the variables that is governing the population, in the sense characterizing the population. So, population is characterized by different variables applicable to the population. For example, if we consider the total students of IIT Kharagpur, all students of IIT Kharagpur, this is my population, all student of IIT Kharagpur, and the Kharagpur students, they come from different their demographics differ, their socio-economic families, socio-economic status differ, their performance in the graduation, that means in IIT Kharagpur exams, that also differ. Okay. So, for performance you may be interested to see that what is the percentage of marks obtained or CGPA, cumulative grade point average, or somewhere related to demographics you may be interested to see that what is the age profile, age. Sometimes we may be interested to know their height profile. So, see height, age, percentage of marks, CGPA, under socio-economic status, family income, all are basically coming under, these are all variables which characterize the students of IIT Kharagpur. So, if we want to understand population, not only the space and time boundary, we also require to understand what are the variables that governs the population. That is what we see basically. And if you consider any of the variables, for let height, I am writing height is the students, and this I am denoting as x, which is a random variable, let it be. Here we are saying it is random because if you just pick up one student, you do not know what is his height, but when you measure you will find out some height, that is it. So, it is a this one x each. So, I want to characterize IIT students in terms of their height, or you may be interested to characterize the students in terms of their number of subjects completed in a year. You will find out that there are many backlog cases, many students could not complete. So, in that sense it may so happen that if we consider the 10 subjects to be completed, it may so happen that you will find some student on no subjects completed, some student 1, or like this may be up to 10, although it will be heavily biased towards 10, but this is possible. Okay. So, depending on the what type of variable, random variable you have considered, and accordingly you require to use certain probability distribution. Last class I told you that if the variable is discrete, suppose x is a discrete variable, discrete random variable, then you have to use discrete probability distribution. We discussed last class, but we have not said what are those probability distribution. Later on we will see. But what you can see very easily that suppose x is discrete variable, it can take value 0, 1, 2, 3 like this. Then if you make a tally chart in the sense frequency 0, 1, 2, 3, 4, 5 like this. Suppose when you are getting 0 counts, you are putting 1 like this, then again suppose 0 count, and similarly like this, like this. What is this? Basically this tally count. What happened that what is the occurrence of 0 2 times, this one 6 times, this one 8 times, this one 4 times, this one 2 times, this one 1 time. So, if you by characterization what do we mean here? We mean that I have my discrete random variable which can take different values, suppose 0, 1, 2, 3, 4, 5, and it appears for different times. I think all of you know this is nothing but the frequency diagram. Frequency diagram, and this frequency diagram, if I know the total numbers, and if you divide each of the frequencies by their total, then you will be getting relative frequency, and that relative frequency will give you that empirical or crude probability distribution, and this distribution is known as probability mass function. Probability mass function. What we have said, this PMF here, you see that discrete variable, when you get this type of plot, you are basically developing probability mass function. But I told you that we will be considering infinite population. So, infinite population means the totality is not known. Second thing is that our variable is random. What will happen next, what value it will assume, we do not know. So, when you are in the population domain, you cannot get that value and immediately you will do. When you are in the population domain, oh yes, we will get the values when you go for the sampling, but at least before sampling you do not have all those values. So, what you can do for a particular variable is concerned, you can expect something. Okay. What is this expectation? Suppose we want to know what is the average height of the IIT students. This is nothing but the expected value of x. So, that expected value of x or the variable way of interest, this is known as mean, that is mu. Mu stands for mean. Mean is expected value of x. When your variable x is discrete variable, so you will get like this x f x, for this is for all I, all x, whatever may be the your number for all x. If you see this example here, you just see this example. So, we are thinking saying here that x can take this value, this value, this value, like this. There are 1, 2, 3, 4, 5, 6 values. So, if I assume that these values are nothing but 0, 1, 2, 3, 4, 5 and so these are all x values, and if I assume that their density here as discrete, they are also the probability values, and their probability values is like this. Suppose the first one is 0.15, second one is 0.20, third one is 0.25, fourth one again you can write 0.20, fifth one suppose 0.15, then what is left? The 20, 40, 60, 95, so 0.05. So, then what is your expected value here? X into f x you have to find out. So, 0 into 0.15 is 0, 1 into 0.2 is 0.2, 2 into 0.25 is 0.50, 3 into 0.2 is 0.60. So, like this again 0.60 and this will be 0.25. If you add, what you will get? You add 5, 6 plus 2, 8, 14, to 19, 21, so 2.15. So, that means your expected value is, if this is 0, this is 1 and this is 2, somewhere here. So, if I draw here, I can say that suppose this is my 0 values, this is 1 values, this one 2 values, and this one is 3 values, this is your 4 and then 5. So, this is 0, 1, 2, somewhere this your value is 2.15. This is what is expectation, but another measure here it is there. So, another one is sigma square. So, we have said here your mu, that is mean, we have just said, as well as let there is another measure which is sigma square, that is the variance. Okay. What is variance? Variance is expected value of x minus mu whole square. So, for this case, your discrete case, you will write x minus mu whole square f x, and you have computed here two things. What are those things? That you computed x, then your this one is the x f x, you know the mu value, mean value you know. Now, you can create x minus mu, that means 0 minus 2.15, that will be minus 2.15, like this you can calculate, and again you square it, multiply it, then add it. So, you will be getting the sigma square, that is variance part. Okay. Then what we have assumed here? We have assumed that x can take these 5 values only. and this is the probability mass function. So, what will be the sum total of these probability values? 1. Then what is mu and sigma or sigma square?
Mu is long run mean.
Correct.
And sigma is
Long run standard deviation. That means you are saying that mean and standard deviation, they will vary for a population for a particular characteristic.
It should not be for a large population.
No, even for small population.
So it should not vary.
It should not vary. It is a constant. When you talk about a parameter, so actually these are here this mu and sigma square. In statistically we say population mean and population variance they are constant. Another issue will be there, they are not known also. Here we have assumed a very finite population, small size population, and we have calculated something like this. Actually population size is infinite. You will not get all values of x, you will never get if the size is infinite. So, that means you cannot measure this, or I can say compute this, but only what you can do, you can expect something. That is why the expectation term is used here, that expectation. Okay. So, if I say population parameter, so now you can understand that these two are population parameter. It is by saying these two are population parameter, please do not consider that there is no other population parameters. These two are some of the population parameters. There are many population parameters, but okay, these two mean and standard deviation or variance, they are population parameters. Why we go for population parameter? Because see, the lecture is today's this topic is very simple topic, calculation point of view, that, but understanding point of view, we must understand that why we require population parameter. We require population parameter because if you know these two parameter and also you know that your x is random variable and that can follow certain probability distribution, and if you know that distribution and also know the parameters, what happened? You do not require to go for that particular system or process for further study for this particular variable is concerned. If I say that the absenteeism in the shop floor for the production shop considered, it follows something like normal distribution, and we know that its mean is mu and sigma square is the variance component, that means I am in a position to know this. So, if I know the distribution, what is actually happening here, that real production shop from worker performance point of view, here the absenteeism is converted to a mathematical equation, statistical equation. That is the advantage. That means, if I know truly I know the what is the probability distribution with respect to a variable and what are the population parameter for that variable, I have the distribution with at my hand. So, I do not require to go further, so long the process will not change. By process will not change, what I mean to say, that suppose it is a machine works over time, machine condition deteriorates. So, that means today a new machine, its performance now after 10 years the machine will not perform at the same level. That means what happened? The characteristics changes. So long the characteristics is not changing, even the distribution itself is enough for you. Okay. Now, if your variable discrete, not discrete, that is continuous, your variable is continuous. You see what is the this one left hand side, this is PMF or PDF, PDF, this is probability density function. Now, why in continuous case we say probability density function, whereas in the discrete case we say probability mass function? You think this one? So, here also if we know that this particular population, it has mean and variance component, and when it is in the continuous level you have to use these two equations for expectation. So, basically integration will come into picture, expected value of x, this is integration minus infinite to plus infinite depending on the range for which the variable is defined, then fx dx, and your sigma square is nothing but again x minus mu whole square, this is infinite to infinite, that x minus mu square fx dx. So, I am saying the parameters mu and sigma square here. I hope that you understand now that what is population, and population is characterized by probability distribution if the random variable has a probability distribution, and if you know that for that variable the parameters of the distribution, you have characterized the population. That is what is known as characterization of population in terms of probability distribution. Now, there are many probability distributions. You see here we have we can see here that under two heads, discrete and continuous. Under discrete distribution, binomial distribution, Poisson distribution, negative binomial, geometric, hypergeometric, many more, a series. Similarly, under continuous, normal, log normal, exponential, Weibull, gamma, there are so many distributions. There are probability distributions. We will not discuss all the distribution, we will only discuss normal distribution here, because in multivariate statistical modeling, normality assumptions, this normality assumption is very, very valid, vital one. Many of the models assume normality of the data, definitely at the multivariate level that will be multivariate normality. So, we will discuss only normal distribution, other distribution you can follow, Johnson book is there, you can follow this, and I am sure all of you are familiar with this distribution. This is what is normal distribution, it looks like this, and this mu is the center point here, and here that it is basically symmetric. So, maximum number of observations also you will find out along this level, and it gradually both side it will gradually reduced, and finally, after 3 sigma level it will almost negligible to 0 level like this. Okay. Now, the how to read this normal distribution, you see that within 1 sigma plus minus 1 sigma, this one is very important, minus 1 sigma to plus 1 sigma, 62 to 0.23% observation falls within this. Then within plus minus 2 sigma level it will be little more than 95%, little more than 95%, but not 96, 95 point something. And if you consider my plus minus 3 sigma level, then your 99.73% observation will fall under this category, this zone.